Hey, good day, ladies and gentlemen. I hope you are still doing good. Today, we'll be doing this question 9, electricity, and then it is from the question paper of Mpumalanga trial. So let's start. A battery with EMF E and internal resistor of 1 ohm is connected to 4 resistors as shown in a circuit below. This is our EMF. This our internal resistor is 1, and then how many resistors are we having? External resistors 1, 2, 3, 4. Do you get me? So then switch S is closed. When they say switch S is closed, they say the current can able to pass through switch S because it is closed. The current can able to pass through switch S, and you see all the voltage, something like that. Then a current of 0.5 A passes through the 6 ohm resistor. Here we know that our what? Our current is what? Is 0.5 A. Do you get me? And then what do we know about a current in a what? In parallel combination. I'm gonna say in parallel combination voltage. Okay, yes, this for parallel combination. Let me name it one. Voltage is the same. Is the same, and in and then the current, our current divide. Our current is not the same. And then in number 2, in series combination, voltage divide and what? Current is the same. Do you get me? So know that the voltage of 6 and the voltage of 12, it is the same because they are in parallel. 6 and 12 are in parallel. Do you get me? They say state Ohm's law anyway. Ohm's law says that the potential difference across the conductor is directly proportional to the current in the conductor at a constant temperature. You will write it. Do you get me? So they say calculate the reading of A1. Where is our A1? Our A1, it is this ammeter here. Since we know that current move from positive terminal to negative terminal, and our positive terminal is the long terminal, that current move from here, from this point, then it passes with the internal resistor of 1 ohm and then comes here. When it reaches this point, it will split. Some, since it was like this, some will enter here, and then the other current will do what? Will go straight. Do you get me? And then though the current that will go straight, it will come like this and reaches A1. It is the current of A1 that we are currently looking for. Do you get me? And then when it reaches this point, some will split, and then some will do what? Will come like this, and then it come like this, it come like this, and then like this, like this, like this, and then when it reaches this point, it combine. Do you get me? And then like this. That's why we know that the current of A1, it is this current here, but it's split into 2. So if we can find the current of 12 ohm and the current of 6 ohm, it will give us the current of A1. Why? Because the current that passes through 6 ohm and the current that passes through 12 ohm, it is the current of A1 when they combine them, when we combine them, because it is splitted here at this point. Do you get me? So we know the what? The current of 6 ohm. What are we short with? Is the current of 12. So let's find the current of 12 ohm. How are we going to find the current of 12 ohm? Let's find the voltage here so that we can take this voltage and use it here, because we say in the parallel combination, voltage is the same. The voltage of 6 and the voltage of 12 is the same. When I say V of what? Of 6 ohm is equal to what? IR. Do you get me? Is equals to IR. What's our voltage? We are looking for it. V of 6 ohm is equals to what? Our current is 0.5. We multiply it with 6, and then we get what? 3 volts. And then we know that here our voltage is what? Is 3 volts. We also have what? 3 volts. This is our voltage. Do you get me? So since we know our voltage at this point, let's find the current. When I say what? Voltage of 12 ohm is equal to what? IR. What's the voltage of 12 ohm is 3 is equal to what's your current? We are looking for it. And then what's your resistor? Your resistor is 12. Do you get me? I'm going to divide here by 12. You can divide here by what? By 12. Do you get me? Then our current, when I say 3 all over what? All over 12, which will give us 0.25. Here we have 0.25. And this is the current of what? Of 12 ohm. The current of 12 ohm is what is 0.25 A. Here, so now we know we have 0.25 A. Since this 0.25 A and this 0.5 A splitted here, when we combine it, it will give us the current of what? Of A1. So let's come here and answer it. Then we're gonna say current of A1 is equals to what? 0.25 A plus what? 0.5 A, which give us what? 0.75 A. I'm gonna get your Tramax. Do you get me? So now here on A1, we know that we have what? 0.75 A. And here on 20, we also have what? 0.75 A. Since I've explained that since the current will split here at this point, it will also come here and combine. Do you get me? The current of 6 and the current of 12, it will meet here at this point. And then it will be what? 0.75. Do you get me? So and then let's go and answer the second question. They say calculate the reading of A2 when the power dissipated in resistor R is 6 watts. Let's come here to resistor R. We have what? We have 16. Is 16 or yeah, 16 watts. We have 16 W. So here we're gonna say 9.2.2. We're gonna use this formula of P is equal to what? VI. Do you get me? Since we know our P, let's substitute it. Our P is what? Is 16, or let's gonna say P of R, okay? And then 16 is R ohm. P of R ohm, I mean. 16 is equal to what's our voltage? We don't know our voltage. And then what's our current? Don't know. But what do we know? That the current that will pass through this R, it is the same as the current that will pass through A2. The current of resistor R is the same as the current of what? Of A2, because it will come like this, passes through the resistor R, and then also passes through A2. Do you get me? That's why I'm saying it is the same. Do you see? Then current of resistor R ohm. This is what we are looking for. What do we know about this voltage? The voltage, we must find the voltage or at this R. But we know that since we have what? We have 3 volts here. We can find the voltage at this point. Do you get me? You can find the voltage at this point. Let's find the voltage at this point of 20. The voltage of 20. We're gonna say V of 20 ohm is equals to what? Is equals to IR. What's our R? 0.75 I, and then what's our R? Our R is 20. And then this is gonna give us what? 0.75 multiplied by 20, we get 15. Do you get me? Here we have what? We have 15 what? Volts is for 20. Here on 20, we're gonna say we have what? 15 V. Do you get me? 15 V. So now, since we have 15 V here, what do we know about what? The voltage. The voltage of here is 3, and then it is also 3. That's why. And then here we have 15. If we can say this 3 plus this 15, it is the same as the voltage of what? The voltage of this resistor R. Someone is now confused. Let me show you in practically. So if we can combine what? If we can combine these two resistors, do you get me? Since they have the same voltage, we're gonna have the circuit like this. Our circuit is going to look like this. Here we're gonna have our what? Our A1. It is A1, yeah, A1. And then since we will combine voltage, we will combine resistor 6 and the resistor of what? The resistor of 12. And then here will be those resistors combined. And then how are we going to find it? We're going to say R in parallel is equals to what? 1 all over 6 plus 1 all over 12, the power negative 1, which we're going to get 4 ohm. Then here we'll have 4 ohm. This 4 ohm is the combination of the 6 resistor and the 12 resistor, the 12 ohm resistor. Do you get me? And then here we have what? We have 20. That resistor of 20 ohm. And then it will split here. Here we have what? We have A what? It is A2. And then here we're gonna have what? Resistor R. Here we have our what? Our battery. Yeah, we have our battery and then an internal resistor. Sorry for not drawing it. This is an internal resistor like this, our small r. So we know that since we have combined those resistors, and 4 and 20, they are now in series, because the voltage of A1, the current of A1 will come here and pass through this point and then this point. That's why I'm saying they are in series, because they are receiving the same what? The same current. When two resistors receive the same current, they are in series. You must take note of that. I wrote it here. In series, current is the same. Do you get me? That's what I'm saying. When two resistors receive the same current, they are in series. If we can combine them, we can combine them in the series combination. We're gonna say what? R of series is equals to R1 plus what? R2. What's your R1? Our R1 is 4 plus what? Plus 20, which is going to give us what? 24. We are now having a what? A circuit like this. Here we have our A1. Here we're gonna have what? A 24 resistor. 24 ohm resistor. Since we combine these two, then we're gonna have something like this. Here's our what? Our A2. And then here's our R, resistor R, like this. Like this. Now we're having something like this. This our small r, internal resistor. Okay, so since our resistor R is this now this one, you know that this resistor R, it is what? It is in parallel with these two, with a resistor of 24 ohm. Do you get me? So the voltage of this resistor of 24 is the same as the voltage of this. That's why I'm saying when we combine the voltage of what? Of this 20 ohm and we add it with this voltage, we find the voltage of this R. And then we know that the voltage of R, voltage of R is what? It is 15 volt plus what? Plus 3 volt. Do you get me? What do we get? We are getting 18 volt. So then we're gonna come here, we're gonna say 16 is equal to our V is 18 multiplied by what? By R, yeah, R ohm. Do you get me? Then we're gonna divide by 18, divide by 18. Our I is what? Our I, we're gonna say 16 all over 18. We get what? 0.89. Here we have 0.89 A. Do you get me? And then mean here 0.89 A, 89 A. And then since here the current of 0.89 A is passing through this resistor, it will also pass through this resistor. It's 0.89 A. That's why you're gonna say what? Our A2, the reading of A2, the reading of A2 is what? Is 0.89 A. Do you get me? So now they say calculate the amp of the bed. Do you get me? There are two formulas to calculate the EMF. We know that we have this formula. Let's say EMF is equals to I R external plus what? Plus R internal. Do you get me? And then since we know that our R external, we've calculated it, it is this one. This our R external. This what it is, this 24 plus what? Plus this R here. We have not calculated the R external, this 24 plus this R. And we can able to find this R. How are we going to find this R? This R is the R resist, this resistor here. We can find it. Do you get me? Since we know the current that is passing through, and we also know the what the voltage of it. We say the voltage is what is 18 here. Do you get me? So then let's calculate our R. Know that our R, it will be what? The voltage of R ohm resistor, it's IR. What's our current? To say our current is 0.89 multiplied by our R. We are looking for it. And then here we have 18. We're gonna divide by 0.89 and divide it by 0.89. And then our R becomes what? 18 all over 0.89. It is 20.24. 20.22, I mean, ohm. So here we come. Now we know the resistor of this is what is 20.22. Since they are in parallel here, let's add them with a parallel combination. When I say 1 all over what? R parallel is equals to 1 all over R1 plus 1 all over what? R2. And then our R parallel will be what? 1 all over 20.22 plus 1 all over what? 24. And then to the power what? -1. And then here we go. 1 all over plus 1 all over 24. The power -1. And then we're gonna get what? We're gonna get 10, what? 98 ohm. And then when we get 10.98 ohm, is our, we're gonna substitute it here. We're gonna say F. What's our I total? Our I total, it is what? It is this current here of A2 and the current that will come here. Do you get me? Because they will I total ne. Since our current will split here and enters here, and then the other one will split in, and then when we are here our current is 0.75. When we are here our current is 0.89. They are going to combine here, and then here we get our I total when we combine this current of 0.89 and 0.75, which will give us what? 0.89 plus 0.75. 0.89 plus 0.75 is what? Is 1.64. Do you get me? Here we're gonna have 1.64. What we said, our R external is what? R external is 10.98. Here we're gonna have what? 10.98 plus what's our R internal? Our R internal, since here we know that our current will be 1, what? We say it will be 1.64. At this point, it will also enter the here with 1.64 because it is not splitting. And then here we have 1.64 what? A. Then our voltage here. Sorry. Yo, sorry. Okay, 1.64. And then okay. What's your R? Our R is 1. Sorry for that. Okay, our F will be what? 1.64 multiplied by what? By 10.98 plus 1. Get 19, excuse 19.6. What? Got 19.64. Do you get me? 19.64 or 19.65. But it was supposed to be 19.64. Okay, what? Volt. Do you get me? Because here it does, just because here I didn't round here at this point. I didn't round. I said answer when I punched the calculator, but if you say 20,22, it will give you something like this. 0,19,64. Do you get me? So and then another way, we have the way to calculate the what? A current, saying what? Sorry. We're calculating a voltage. I mean, because what's going on here? Hey. With the way of calculating a voltage, saying V amp is equals to what? V internal plus what? V external. Do you get me? And then what's our V internal? Our V internal, they want the voltage at this point. Our voltage at this point will be what? V is equals to IR. And then what's your I is 1,64 multiplied by 1. And then we're gonna have 1,64. Here's 6. We're gonna have 1,64 plus what's your V external? Your V external, it is what? It is 18. Do you get me? It is 18, your V external. We're gonna come to this simplified diagram. Here we said the voltage that is going through here is 18, and then here is also 18. That's why we're gonna say our V, it is 18 volts. Do you get me? And then when we add this 1,64 plus 18, gonna have what? 19, what? I mean 64. Do you get me? Volt. So don't forget to subscribe. If you have a question, you can send it to 07155206921. May God bless you. Thank you. How's